something very similar. The orange screen may be a little different on some of the components in here, but I explained that. Um, but for most of it, you're going to see a breadboard area, the area where you build your circuits. We're going to put the components and run the simulation. And obviously, you're going to need components, and you're also going to need instruments to measure voltage, current, and anything else you need to measure. And on this area, as you can see on the right-hand side, it is vertical area here has the instruments that you can use to measure different things like current, voltage, and so forth. And it can get very sophisticated. There are devices here that can be used for a lot of applications in circuit design. And not only for analog circuits, but also for digital circuits and for other applications, electronics in general. And so, obviously, in this introduction, you're not going to be using all of this instrument, but we're going to be using a few, maybe a couple of them here. But this is where you get the instrument from, and you'll see how that works in a minute. On this side of the screen, you'll see the components, right? Yeah, here I'll show you in a minute how you can start grabbing components from this area and placing them in the area where you build the circuit. And there are also some other things that I'll measure as I go along. This menu here and the items you see in the menu can be customized. And I'll also show you how you can customize some of these components you see in the menu itself. But let's start just by creating a simple circuit, okay? I know we have one in the previous slide that we're gonna try to implement, and it's a it's this one here, 3 resistor circuit with a voltage source. But before we do that, I'm gonna start even simpler than that. And I'm going to just build a 2 resistor circuit with 2 resistors in parallel. And I'm going to just, so again, if I'm going to use 2 resistors in parallel, then I'm going to obviously need 2 resistors, and I'm going to use a source. And in this case, we're building a DC circuit, so I'm going to use a battery, right? So as you see on this side here, if you look on this first item here, if I click on that one, it shows me the components, the sources that I can use. As you can see here, you have all kinds of sources, right? You have your power sources, you have DC, you have AC, you have digital ground, regular ground, and so forth. And some other ones here that you can use for other applications. You also have all kinds of sources. You have different AC sources and a lot of other signals that you can use to control circuits. And again, this is for more advanced applications. One of the things, let me put the source first in. So we need a DC source, right? So I select DC source here. And as I select it, if I click OK, it's simply gonna show it, you know, on the tip of the mouse cursor, and I can place it anywhere I want. So I'm gonna place it here, and then it's gonna show up again in the menu, kind of asking me if I want to put it on the source. Well, I don't need a source, but I do need a ground, so I'm going to check ground, and again, I'm going to click OK, and I'm going to select where I want to put the ground, right? So I can select where I put the ground by moving the cursor again. So I'm just going to leave it here for a moment, and I'm going to close this, exit out of here. The one thing I wanted to show you is that I mentioned that you have, as you see in all the components here, you have components for analog circuits, you have components for digital circuits, you have components for mechanical systems, and antennas, and all kinds of applications that you can use, and some advanced peripherals that you can use to design your circuit. So going back to our circuit, right? So I already placed the voltage source, and I placed the ground here. And let's say I want to I don't want the default 12-volt source. I want to change that. So I'm going to change it by simply, one of the ways that you can change it is by simply double clicking on the source itself, and you can see the menu. I'm going to change that 12 to a 10, and that's all I'm going to do right now. I'm going to just leave it as a 10. I can also change the display name that I'm going to give it, and add a few other things like a label. So in this case, it's labeled automatically as V1, but I can change it to whatever I want. Okay. I'm just going to leave it as V1, and I'm going to say OK. So now I have a 10-volt source. So I need two resistors, like I said. I'm going to build a 2-resistor parallel resistor circuit. So I'm going to need 2 resistors. I'm going to go here with as the resistor symbol. But by really choosing this option, I see more than just resistors. I'll see in a minute. If I click on this icon here, as you can see, it came up with a resistor, and it gives me all of the standard manufacturer resistors that you can buy, or you can put your own value if you want. But as you can see also here, you have a whole database of components here. We can put switches, we can put transformers, relays, all kinds of things, capacitors, inductors, and many other devices, pots, variable resistors, and so forth, right? All kinds of elements that you can use to put in your circuits. So going back to our resistors, which I need, and I'm just going to choose, let's say I want to choose a 2TK resistor, and I'm just going to place it anywhere for a minute. I'm going to choose another one, let's make it 3 or 4, whatever. Let's make it 4 resistance. So this is our 2, and that's all I need for this particular circuit. Now you notice here that by default they came out as horizontal orientation, but you can change the orientation to make it look a lot nicer. So I'm going to select the device by clicking on the center of the element here, 1, and as I double click on it, it's going to give me options. And one of the options is, again, I can change the label. Instead of saying R1, I can call it RA, whatever I want. So I'm just leaving it as R1 for the moment. If you right click on the device itself, I also have some other options, and one of them is I can rotate the element clockwise or counterclockwise. If I do clockwise, as you can see, then I can really show how it will look the circuit with 2 parallel resistors. I'm going to do the same with R2. I'm going to right click on it, and I'm going to rotate it 90 degrees clockwise. And again, as you can see, I have my other resistors. So now I have sort of what I like the circuit to look like, right? And I can now, I'm now ready to make the connection. So I simply, to make the connection, I simply grab, as you can see here, either one side of the voltage source or one side of the resistor, and bring it to the other side. So I'm bringing the positive side of the voltage source to this side of the resistor, and as soon as I sense a connection, I'll let it go, and it makes a automatic connection. And now I'm going to go for R2 connecting to R1, and again I'm going to let it go, and it makes a connection. I'm going to do the same with the negative of the source to the bottom of resistor 1, and from resistor 2, grabbing the end, I'm going to go to resistor 1. Okay, now it may not look nice right now, but I'll show you in a minute how you can fix that. And the last thing I want to do, I want to connect my ground. So I'm going to go from my ground to this point, and I have a ground connection. And maybe I want it to look a little better than that, and you can select the wires, for instance, and you can move them around. You can move this on the wire down. You can see, move this other wire down. And I can also move the elements themselves, like so. And it may not be the best looking, but you see how, you can start, you know, um, moving things around so you can make it look a little nicer. And actually, I kind of don't like that. If you don't like something, you can, as you select it, if I either select delete on the keyboard, I lose that connection. I'm gonna see, I don't like that connection, so I'm gonna just delete it, right? And I'm gonna delete this connection again just to show you. If I select it and click delete, I delete it. I'm gonna move the ground somewhere else, and I'm gonna move this a little more vertical connected to the top node, and then I'm gonna connect again. I'm gonna go to my resistor, um, my resistor 1, and then from resistor 2, again, I'm gonna make it connected to resistor 1. And it looks a little better, right? Okay. And again, I'm gonna connect my ground. It's important that you have a ground. Without a ground, this is not gonna work. And my circuit is really ready to go. Some of the other things you can do, I'm gonna run the simulation in just a minute, is to place information about your circuit. Let's say I want to comment something, and so the comment, and I want to put a comment, whatever I want, and I want to say something like, if I double click on this, it's going to bring this menu, and I can put a comment like, check for current, or something like that, something that you want to do or you want to remember later about your design, right? And so as I click apply, okay, then it has this comment here, and again, you can move it around, and you can again have a collection of comments if you want, right? For whatever purpose you need. Other things you can do is you can place text. So I can say, for instance, if I want to have a title for this circuit, I can have, for example, parallel example, right? And I can change the font if I want, and make it larger or smaller. And again, these are the things that are not important as far as the results you're going to get with the actual circuit, but it's going to make your circuits look better, especially if you're doing something like a homework, or you're writing something that you're going to include this graphic of your design, some other paper or somewhere else, and you want to make it look as nice as possible. So those are the few things you can do. I'm going to show you later. I'm going to show you some other things, but for now, you see how you can customize the look in your circuit. So now I'm ready to look at the information I want, but I haven't decided what is it I want to measure, right? So let's say I want to measure the voltage. Well, they're parallel, so the voltage obviously here is going to be the same. So let's just check whether that's true or not. I want to check the voltage across resistor 2, and I want to change the current coming out of the source. So there's a couple of ways I can do this, okay? I can select, if you look at the menu here, there's a square icon that says place indicator. And what that will give me is it will give me digital displays where I can see a voltmeter display, an ammeter display, and some other things. So let me just click on that one. And as you can see here, I have options here, what I want to see. So I want to see a voltmeter. And then also, as you can see, it gives you options on how you want to see it. It shows you this first default example. It shows you the connections on top and bottom, with the top being positive and the bottom being negative. If I do voltmeter VR, you'll see the reverse, right? The top is negative and the bottom is positive. If I do horizontal, it shows me the connections on each of the ends. On the left-hand side is positive, on the right-hand side is negative. And on the HR, it does the opposite, right? So you can choose the connections or the specific way that the voltmeter will be displayed depending on the circuit itself. In some cases, it's going to be easier to use this mode. In some cases, it's going to be easier to use this mode, right? In this case, since I'm measuring the voltage right across the resistor, I'm going to use this mode. I'm going to click OK, and here I have options, right? I can either place it anywhere I want and just bring the connections like I did before, bring this wire to this end, and bring this top wire to the top of R2. I can also do something that I can use very easily by bringing the circuit to whatever I want and choosing the connection. See how it shows the connection to the top? And just click the connection. Oops. And I just then click the connection at the bottom, like so. And now I'm measuring right across. Obviously, that kind of obfuscated the information about R2, but I can move it. If I select it, I can move R2 as far as I want, so I still have information. I can move the meter again, move R2 again to give it more room, and so forth. So you can see now I have a connection for my voltmeter like that, and it's going to measure the voltage across R1 and R2, which I already know is 10 volts. So now I'm going to do the same thing. I'm going to repeat adding an indicator, and this time I'm going to use the ammeter to measure the current. Okay, and I'm going to click OK. And since this is the way I want to connect the ammeter from current, then this connection seems okay because of the way I want to measure the current out of the source. Now, if you've taken DC or if you haven't taken your lab yet, for those that have taken the lab, remember that when you measure current, it always plays the meter in series with the devices you're going to measure, right? In series with the circuit. To measure current is always in series. So I'm going to just, the nice thing about this is I can simply insert, see how if I insert the meter right here, puts it right in series, right? I don't have to do anything else. So right now I have selected the meters, ammeter here and the voltmeter here, and they're both ready to take measurement. If you click on this label here, in a minute, I can change that label, and I can change that to whatever I want. Ammeter 1, for instance. Click OK. I'm sorry, there shouldn't be any spaces. I want to use _1. And now you can see how it changed the, and I have a typo, as you can see, so I can change that again. I have an extra M in there, so I'm going to just get rid of it and click OK. And now I have an ammeter 1. You can do the same thing for the other one, right? All right, so I'm ready now to take measurements. And all I need to do now is just simply click on this run button, the green button here. It says run, and if I click on run, it's going to just take the measurements. If I click on run, as you can see, it's measuring 10 volts, right, as we know, across R1, R2, with a current of 7.5 milliamps, which it should be, right, because the combination, by the way, you can also measure resistance, I'll show you in a minute. So that's how easy you can do this. Now, I'm going to stop it. So to stop it, I'm going to click on stop button here. And my simulation is finished. And now, notice here also at the bottom, you have an area here. It's called the spreadsheet area. If you don't want to see it, you can go under view and just uncheck it, and you don't see that anymore. And you see more of the protocol. But if you want to see it back again, you go under view, spreadsheet. One of the things that it gives you, especially if you have a very large circuit, it keeps track of all the components you have. So if you click on components, it shows you all the components and all the meters you have in your circuit. And this is useful because you can export this to like a spreadsheet and keep track of your components. And especially, like I said, if it's a very large circuit, you can manage the different components you have in the circuit. From here also, if you click, for instance, if I do replace component, if I click on one of the items, if I double click on it here, I can change the value. So let's say I want to change R1 instead of being 2, which is the 1 now. I'm gonna change it to a let's do a 4, right? Okay. And I'm gonna click OK. And as you can see, change R1 to 4. And if I run the simulation again, obviously, it's going to give me a different result for my current. The voltage is not going to change, but as you can see, the current changed because now I have an effective resistance, an effective total resistance of 2 kilo ohms, and 10 into 2 gives me 5 milliamps. Okay, so that's a quick way. Again, if you don't want to see this, sometimes myself, I don't like to see it here because it's kind of a distraction in some cases. I can click view and simply unselect it, and I have more space here. All right, I'm going to stop my simulation. I'm going to delete this indicators by simply, if I select it and either right click and hit delete, or select it and from the keyboard hit delete, it gets rid of the meters. I'm going to connect the circuit back as I had it before. And now, instead of using those indicators, I'm going to use a multimeter. And if you go here under the instrument, right, you see the first thing you have is a multimeter, right? And if I click on it and drag it here, I click and just drag it wherever you're going to need it. So I know I want to measure the voltage across here, so I'm going to place it around somewhere right here. It doesn't have to be exact, I can always move it. Okay. And I'm going to get another one for to measure my current around here. So I'm going to put it right here. And by the way, you can select as many as you want. Okay. So I'm just going to delete that one because I delete that one, but you can select as many as you want. So again, I want to measure the voltage across R2. So by the way, if it's more convenient, you can rotate this, right? So now the connections are easier to make, although that's unnecessary, really. So I'm going to hit this one at the bottom of the resistance and this one with the top of the resistance. And that's going to measure my voltage. And on this one, remember, I'm going to have to break the circuit because I want to measure the current coming out of the source. I'm going to delete this connection, but then I'm going to connect it back through the ammeter, right? So I'm going to put it back in the circuit, right? Because now it's in series with this connection is in series with this meter in place. And again, if I want to see the information here, what I have to do is double click on each of the devices, each of the instruments. If I double click on this one, I know it's going to give me, I know I have 1 voltage, so I want to make sure that I click on V for voltage, and I also click on this bar, the straight bar for DC. As you may imagine, this wiggly sine wave is for AC voltage. I'm not measuring AC voltage, I'm measuring DC voltage. So I'm selecting V and the straight line. As you can see, obviously, I can also measure current, and I can measure resistance, and I can measure power with this kind of meter. So this one again, I have set it up to volts to measure voltage. This one, I'm gonna double click on it and I'm gonna select A for current. And again, making sure that I'm using this selection for DC. So this meter is set up to measure current DC. This one is set up to measure voltage. It's very important. And now again, I'm ready to measure. And if I run the simulation, again, I'm gonna click run, and in a minute, you're gonna see the results. Okay, again, results are obviously the same, but displayed in a different way. And this is something that I found really, really extremely useful in cases where, for instance, you may not necessarily be building a circuit, but in cases where you have a complicated circuit, for instance, and you do an analysis on paper, like for homework, and you can just bring the circuit and quickly put it in this kind of design in the circuit and quickly see the results and see if your understanding is going in the right direction. It's a good way to check your work, to make sure you're understanding and doing analysis of circuits. Simple circuits like this are more complicated than that. The third way I'm going to show you how to measure current and voltage. Again, I'm going to delete this, guys. No, I'm not going to need them. I can keep them, by the way. You can have multiple kinds of meters if you want, but I'm going to just get rid of them so it doesn't look too busy. So I'm going to delete this. I'm going to delete this guy also. And I'm going to put the connection back. And that's my original circuit. And there's another way I can do this very quickly. And I can use probes. And you can see here on this side of the menu, you have this different probes. This one says it's for voltage. So I'm going to measure voltage. I'm just going to drag it, select it and drag it. And if it doesn't turn yellow, it's not ready. Okay. See? When it's ready for you to let it go, it's going to turn yellow. So just click on it. And this is labeled PR2 and it's going to measure voltage. Okay. And if you double click on it, you can see the definition, right? So you can say, for instance, I'm going to label that B2, right? And let's apply and say OK. So this is the probe that is measure voltage 2. I'm going to select this one just to show you. When I select another one, I want to measure the voltage across here, which we know what it is, but just to show you, I'm going to call that one since we have a V1, well, let me call that V1 and apply, but since it already exists, it won't let me do it. So let me just call that one VA. Doesn't really matter what I call it at this point. Okay, just to differentiate. Now, I'm going to add a probe for a current. So I'm going to select this one and bring it into the circuit. And again, as soon as it turns yellow, it's going to measure the current coming out of the supply. And I'm going to select another one, and I'm going to put it here when I'm going to measure the current to R2. And let's see. And I'm going to try to, if I can flip it vertically. Yeah. See? That way it's not on the way with the top one. But by just right clicking on the device here and select that flip vertically, then as you can see, it moved it out of the way. So I selected 4 probes, right? You have other options here. You can measure power, and you have some other options here for digital devices too. All right, so now I'm ready to, again, if I run the simulation, it's gonna give you the mission. Right? So run the simulation, and as you can see, you have the results. It's a 5 milliamps through here, as we expected. It's 10 volts for VA across our one. is 10 volts across R2, and the current through the R2 resistance is 2.5, as we expected, because they're equal resistances. So the 5 milliamps distribute equally between these two 14 resistors. So we have a current of 2.5 milliamps. Very nice, right? Okay. So that's really a quick overview of the things you can do. One more thing I can do is if I wanted to, again, if you have more complicated circuits, if you want to keep track of all the data that the circuits are generated, you can, for instance, simulate analysis and then later bring those analysis for other, maybe you're gonna run it through MATLAB or some other program to work with the data that you're generating. But if you click on simulate an analysis, you can do different analysis here. Obviously, you know, some of these are a little more advanced, like noise analysis and Fourier analysis, things that you may be able to do later in other classes. But this is the nice thing about multisim, is that it can be, it's not only for circuits, which is extraordinarily great, but it's also for other classes. Like if you do a Fourier analysis in a particular system, if you want to do noise analysis, when you take or have you taken AC, you can do some very nice AC analysis and so forth. But if we do DC operating point here, what you'll see is the things that you can include to be measured in the forms of data. If those are already selected, see, I'm gonna get rid of one here. I'm gonna remove. Okay, that's fine. I'm gonna run that one. If I run it, in a minute, you're gonna see, you know, the measurements that we have given by the different devices, right? But this time is in a table format, right? And it's something you can later export very nicely with the actual results. Okay, that's a very quick overview of how quickly you can build a circuit, and you can actually start. Okay, so now we're going to do a little more complicated circuit. Eventually, I want to show you, even, I know some of you are not taken or haven't not taken AC yet, but I do want to take the opportunity to show you at least some of the things you can do with AC, even if you haven't taken AC. At least I want to show you some of the instruments that are available. So when you take it, you at least have an idea of how to use this, or use it as a reference when you have to use multisim for AC application.